Okay, another lesson today. I just want to recap that um, where we were last class was we were looking at the median and five number summary. Now, the median and five number summary are two measures of center and spread. We are continuing that. There are other measures of center and spread. They are the mean and standard deviation. We are going to start looking at those today. Before I get into the notes, keep a look at Canvas. On Canvas right here, you have guided notes for 2.2 day 2, guided notes right there. You want to open up those guided notes and have them out and ready to use with this lecture. So, as I start the lecture, remember, last class, median and five number summary are two measures of center and spread. Also measures of center and spread. So we start off by looking at what is the mean. So let's recap the mean. You've probably seen the mean before. The mean is when you take all of the data set and you add them all up and divide by how much data you have. So in this case, what we'd be looking at is 5 plus 8. So I'll save some time for everyone. You would add all of these up, add them all together, and then you would get a total, okay, equals, and then you take that total and divide by how many points you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our total is 52. You divide it by 10, you get 5.2. Now, the mean is called X bar in stats, and it looks like this, X with a bar on top. So again, that is the mean. Last class we did the median. Today we look at the mean. This is not the middle number anymore, right? This is the weighted average because it's 52 divided by 10 points. The mean. So why do we have the mean and median? The mean and median exist because of what is called resistance. The median is considered resistant and the mean is not. I'll show you an example of why. If I was to think about, five people's income in a small office, right? Let's say it's a doctor's office. Let's say there's a secretary who makes a secretary or an office assistant. Let's say there's an office assistant who makes $50,000 in a year. There's three nurses that make 75, 80, and 85, all 1,000. We'll say they're all in thousands. And then the doctor, let's say it's a very, exclusive office, maybe a plastic surgeon or something. We'll say the doctor brings in $850,000 a year. If I was to go and find the median of the office, right, the median is the middle, the median would be $80,000, 80K. And that would be for the center of this office. It would be about what is the center income for the office. The mean incorporates the extreme values because if I was to put this data into the calculator, 50,000 plus 75,000 plus 80,000 plus 85,000 plus 850,000 and divide it by 5, add them all up and divide by how many you have, the mean X bar for this would be $228,000. The mean here, capital M for median, the median was $80,000. If I had to think about which of these two numbers, 228 or 80, describes the center of the distribution, because that's what these two numbers are for, the center, would you say that in this doctor's office of 5 people, the center of the distribution is closer to 80,000 or closer to 228,000? The center. It's probably going to be 80 because the mean incorporates large and small extreme values. The median, think when we calculate median, the first thing you do is cross that out. You cross off the extreme values. Then you cross off even more extreme values and you're left with the center. So the median is called resistant. It's not affected by huge, huge numbers. We're going to learn about the standard deviation today. So with the mean goes the standard deviation. I'm going to write something very important that you have to remember. The median, okay, the median, oops. Messed it up. Here we go. I'm going to write something very important on the screen right now. The median of a data set, computer is struggling. Okay. The median, which is that center we talked about last time, goes with the 5-number summary. That's the spread. They never change. The mean will go with this standard deviation. Always. They're in joint pairs. Median and 5-number summary, always together. Mean and standard deviation, always together. So what is the standard deviation? It measures the average distance of observations from their mean. It does an average of all the gaps between the mean and the values. So I'm going to show you how it's calculated. It's a very confusing formula, but we're going to break it down very easy. To find the standard deviation of observations, what you're going to do is you find the mean first. You need to know what the mean is. Then you find the distance of each observation from its mean, and we square it. We add them all up. That's Greek letter sigma. It means add them all up. And then you divide by the number of observations minus 1 and take the square root. This shows it in more steps. This is even more. So step 1, you need x bar. Step 2, do x minus its mean squared. That's where you get the squared distances. You add them all up. Greek letter sigma means add. You divide by number of observations. N in this class will always just be sample size. So it's how many points there were. N will always be sample size. And then you square root, and that's the standard deviation. We're going to take this class of statistics kids, test scores, and we are going to calculate the standard deviation. We're going to do it. I made a table to help us get through it. The first thing we're going to need to do at each of these data points is find the mean. So I need to add them all up. Add them all up. Add them all up. And then once you get the sum, you're going to divide it by which is the sum here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our sum is going to be 909.7. And then you take that and you divide it by 11. And it is equal to 82.7. What is 82.7? That is going to equal our x bar. That is the mean. We need that. Okay? So now we need to do this for each data point. So I'm going to organize into a table. 72, 85, 84, 92, 65, 85, 95, 64, 79, 98, 91. And for each of them, what I'm going to have to do is subtract the mean. And then I'm going to have to square it. So I'm going to do this in a couple of steps. So 72 minus, my mean is 82.7. You'll have to get that number, and then 72 minus 82.7, we'll have to square it, and we'll get a new number. So I'm going to leave room for the answer. 72 minus 82.7. And then we're going to square it. So I'm going to do all of these. I'm not going to waste your time. I'm showing you that I did them all already. So 72 minus 82.7 is negative 10. Negative 10.4. Then I have 2.57 for the next one. 84 is 1.57. 9.57. Negative 17.4. 2.57 again. 95 is 12.57. 64 is negative 18.4. 79 is negative 3.4. 98 is 15.6. And 91 is 8.57. So this is x minus the mean right here. See, x minus x bar. Now I need to square all of these answers. So save you some time. I already did it. So I'm going to write them all in. I'm going to square all of these answers. 108.7. First one, 108.7. Just squaring these little numbers. 6.6. 2.5. 91.6. This is 303.8. 6.6. 158. 339.6. 11.7. 242.4. 73.4. And then the next step says to sum these all up. When I sum them all up, which I already did for us, I got 1345.15. So let's think what we've done. We've done a lot of work here already. I had it pre-made, but this would have taken a long time. You take every observation, you have to find the mean. Then you do the observation, each test score, minus the mean. And you square it. Now I sum them all up. After I sum them all up, it said to do, we're almost done. This is now we're really close. It said to do the sum, 1345.15, and divide it by n minus 1. N is always the sample size. So this was n is equal to 11 because I had 11 test scores. So I divide by 10, n minus 1. When I divide by 10, I get 134.51. That's called the variance. We'll talk more about variance later, because when I square root it, I will get the standard deviation here of 11.59. That is S, standard deviation. X bar was 82.7 again. So what do these two numbers mean? It means on this test, the center of the distribution, the mean was 82.7, and the average distance of scores away from the mean was 11 points. So we had 82 points as the center, and the average distance of people away from the mean was 11 points. That's what the standard deviation is, the average distance away from the mean. This is how you calculate standard deviation by hand. If you want to have this video to stay up to see how to do it, again, you should pull this video back up, but we are going to practice this now. We're going to practice this now on Canvas with a worksheet, how to calculate standard deviation by hand.